Hi there, everybody. Good morning. Mr. Lewis here again to go through our final section of Unit 1, Section 1.6, which is consumer choice and marginal analysis. And we started talking a little bit yesterday about marginal analysis as well, but today we're going to talk about how consumers maximize benefit. For producers, it's a little bit easier. It's total revenue versus total cost, right? Profits, maximizing your profits. That's a little more straightforward compared to what we have to do with consumers. So this is it. This is our last skill that we're going to learn for Unit 1. And then we will practice this and get some levels in Buzz. Next week, going into next week, you will have a test. But we're going to do that at the end of the week. We're going to do that on Friday because I want to make sure that I can see B group and A group both one more time in person so we can review for the test. And I'm not going to see A group on Monday because it's Labor Day. So happy Labor Day. Hope you have good plans and can do at least something fun in the context of everything. But enjoy your 3-day weekend. I will have nothing posted on Monday, nor should really any teacher unless they're just trying to give you something cool to do or if you ask for something to work on. But don't worry about Monday. I know I had some students asking, are we still going to have things on Buzz? No, it's Labor Day, so you have no labor on that day. All right, let's jump into 1.6. Okay, section 1.6, marginal analysis and consumer choice. Think about how we got here. 1.1 was scarcity, right? We talked about resource allocation and what to do with scarce resources. And then we talked about what producers do with scarce resources. Then we started comparing both sides of the analysis and exchanges, trade that occurs. And now we're on consumers. So let's take a look. Yesterday, we learned about marginal analysis for the first time. And you learned about this thing called the marginal principle that says that the net benefit of any activity is realized at the last unit at which the marginal benefit of that activity is greater than or ideally equal to the marginal cost. We want to do something up until the point that we're not getting anything out of it anymore. Okay, if we continue beyond that point, we're going to lose. So we want to stop before that happens. With pollution reduction, right, it goes from 1 through 6, 1 unit at a time. Here's our total benefit. Here's our total cost. So if you have these numbers, the total approach is great. You could do 20 minus 9, 38 minus 20, 54 minus 33, 68 minus 48, and you would realize that here at the third unit, our total net benefit, the difference between these two, is the greatest at 21. And there are those numbers just to prove that. Okay, that is total net benefit, which is more important than total benefit. And that's proven here, right? If at the third unit, that's our greatest total net benefit. If you continue beyond that, you can see our total benefit does grow, but it's not as great of an overall net benefit. So we're not going to keep going with that. We're going to stop there. Now, just to show you this marginal principle in action, watch what happens to the marginal benefit compared to the marginal cost as we move down this chart. So the marginal benefit would just be the change in total benefit as we move from one unit to the next. So 0 to 20, 20. 20 to 38, 18. 38 to 54, 16, so on and so forth. Marginal cost, as you can see already, is the change in total cost. So 9, and then 9 to 20 is 11. 20 to 33 is 13. Now watch what happens here. At the third unit, the marginal benefit of that third unit is greater than the marginal cost. But if we do it a fourth time, the marginal benefit slips below the marginal cost. And so that's a -1 net benefit for that unit. So it's chipping away at our total net benefit, right? It goes down from 21 to 20, and then to 15, then to 6. And we don't want to keep doing that. So we're going to stop at the last point where marginal benefit is greater than or equal to the marginal cost of that activity. It doesn't matter what we're measuring it in. This could be dollars. It could be anything. We really don't care because it's our marginal benefit and our marginal cost, and that's the principle we follow. we're not going to do something if the marginal benefit is less than the marginal cost. So we choose 3 units, okay? So I just wanted to give you a quick review of that because it's going to be important leading into what we're doing today. Getting into consumers, just like producers, consumers face constraints. Okay, producers face constraints on the production possibility curve. Consumers also deal with scarcity in the form of budgets. We only make so much money, and we have to determine how to best allocate our money. And so we set these budgets for things. It might be grocery budgets, it might be travel budgets, things like that. But we allocate to get the most utility that we can. And remember, utility is just satisfaction for a consumer. Okay, it's joy, it's satisfaction. Now, we make a big assumption that consumers are, 1, rational, and 2, that they want to maximize their utility. Basically what we're saying is we assume a lot of things in economics to just kind of get rid of maybe bad actors out there, people that just are weird in their consumption patterns. For example, they'll demand something more if the price goes up, things like that. So we kind of assume that people are following our rules here. I just wanted to clarify that. But we need to see how consumers go about maximizing their benefit. Producers do it by maximizing profit. Duh, right? Consumers, though, wish to do this through utility. So let's take a look. First of all, with these budget curves, all right, it's sort of like a production possibility curve, actually. You can see that we've got 2 goods, movies on the y-axis and t-shirts on the x-axis. Over here, what this is telling us at the end of this budget line, this budget curve, is that if Jose puts all of his money into movies, he can buy 8 movies. If he puts all of his money into t-shirts, he can buy 4 t-shirts. And then there's all these different combinations in between, right? Like this one is 2 t-shirts and 4 movies. So one thing we know right away is that t-shirts must cost twice as much as movies. Because if this is his budget and he can buy 4 t-shirts or 8 movies, movies must cost half as much as t-shirts. All right, now over here in the green, this is beyond his budget, so it's impossible, just like we talked about with production possibility curves. Down here, this is feasible, as they say, or possible, but it's not optimal. Okay, these combinations that are on his budget curve are all efficient. At least he's using all of the money that he set aside for this budget. And you might be thinking, well, wouldn't it be good to save money? No, we don't care about that right now. He set this budget aside, and what we are trying to figure out is how to maximize his utility. That's what we're tasked with. Okay, what combination here with this budget will maximize Jose's utility? We don't care about saving him money because that's not going to generate joy in this scenario. He needs to purchase more movies and t-shirts to generate greater utility. So, a reminder of how utility works. As we consume more of something, total utility continues to go up, and then it reaches a maximum point, and then it drops. That maximum point is called the point of satiety. Okay, and the marginal utility curve is constantly downward sloping because as each additional unit of a good is consumed, as it says up here on the right, marginal utility will continue to decrease. That is a rule. It's called it's actually a law, It's called the law of diminishing marginal returns, the law of diminishing marginal utility. So at some point, that's always going to happen. For utility, it's one after another. The first unit is better than the second is better than the third is better than the fourth, and that continues. It's a rule. It's a law. So the total utility curve, in a lot of ways, reflects the marginal utility curve. And then as soon as marginal utility goes negative and we experience dissatisfaction, the total utility curve starts downward sloping. So again, what we're tasked with is figuring out what combination of these goods will maximize Jose's utility. On this utility curve, this is for one good. So it's easy to say, oh, yeah, they're maximizing utility right there. But this is just for one good. This is a much different question. When we're asked what combination of these items will maximize Jose's total utility, that's a very different thing. And there's a rule for us to follow. So we call this consumer equilibrium, maximizing utility. The equimarginal rule says that these two things have to be true for consumers to be maximizing utility within this budget for a combination of goods. One, use the entire budget. The entire budget must be spent. That's it. We talked about that actually already. Two, they must consume the combination of goods at which the marginal utility per dollar of the last unit consumed of each good is equal. So marginal utility per dollar is bang per buck. That's just bang per buck, as we say. This is the technical term, marginal utility per dollar. That is the correct way to say it. We call it bang per buck just casually. But what they're saying is that if we were to say buy 4 movies and 2 t-shirts, if that's our combination, right, then the bang per buck of the second t-shirt must be exactly the same as the bang per buck of the 4th movie. Otherwise, we are not maximizing utility. This is part of marginal analysis, being able to equal out the last marginal benefit per dollar of those two goods. Usually marginal analysis might be, okay, what was the marginal benefit versus the marginal cost? We're doing that to say marginal utility per dollar. That is marginal analysis. That is cost-benefit analysis. Marginal utility, benefit per dollar, cost, benefit versus cost. This rule, though, is saying that has to be equal for both goods. So I'm going to show you how we walk through that. We don't use this. Okay, this is nice. The budget line may come in handy, but for our purposes, for what we're trying to do here, which is maximize utility between two goods, okay, t-shirts and movies, we have to do something much different. And we're going to use a chart that looks like this. What you'll be given in a question like this are a few things. One, the budget. Jose's budget is $16. It says he has $16 to spend on movies and t-shirts. Movies cost $2, while t-shirts cost $4. What combination of the two goods will maximize his utility given the information in the table below? So we have units consumed over here on the left, 0, 1, 2, 3, 4, 5. We have total utility for movies. We have total utility for t-shirts. And then we have a space to do marginal benefit per dollar. Now, marginal benefit per dollar is marginal utility divided by price. Marginal benefit per dollar. So the first thing I always do is take total utility and convert it to margin, because we need the margins. So I'm just going to create my own column here and label that MU for movies. And I'm going to do the same thing over here for t-shirts. Now let's go down. The changes. 0 to 20, 20, 20 to 28, 8, 28 to 34, 6, 34 to 38, 4, 38 to 42. Over here for t-shirts, 0 to 28, 28, 28 to 48, 20, 48 to 64, 16, 64 to 72, 8, 72 to 76, 4. Now that we have our marginal utilities, we can take that and divide by the price of each respective good here. And this is what we end up with. 20 over 2, so the cost of each movie is $2, the price. 20 over 2 is 10. 8 over 2 is 4. 6 over 2 is 3. 4 over 2 is 2. 2 over 2 is 1. And these are all measured in utils per dollar, marginal utility per dollar. Over here, the price of each t-shirt is $4. So 28 over 4, 7 utils per dollar. 20 over 4, 5 utils per dollar, so on and so forth. Okay, now that we've done this, remember what we saw on the last slide. The equimarginal rule says we have to use the whole budget and we have to find the combination where marginal utility per dollar is equal. We just found a bunch of those points actually. Here's marginal benefit per dollar, marginal utility per dollar. Okay, there's none that match up at 10, but there are 2 4s, there are 2 2s, and there are 2 1s. So we have 3 combination possibilities that this could be. All right, there they are. So when we go through this, the first thing you want to recognize is some of these match up, and then just, put a star next to them, circle them, whatever you need to do to point that out to yourself. So let's start from the bottom here. If we have 3 possible combinations, our green, red, and purple here, that means that if any of those combinations also spend a total of $16, which is Jose's budget, then we found it. That's our answer. So, at 1 util per dollar, when these are both 1 util per dollar, we're buying 5 units of both of them. So the problem with that is, if we buy 5 t-shirts, for example, they're $4 each. So that's $20 already, and that's over our budget. We'd actually be spending 5 times 4 for the t-shirts, 20, and then 5 times 2, $10 for the movies, and we have a total budget of $30, which is way over our budget. So that one's not going to work. Let's try our red combination here. 2 utils per dollar. Okay? Both of those are at 4 units. So if we buy 4 t-shirts, that's $16, which is great. That's the same as our budget, but this says we also have to buy 4 movies, which is $8, so we're actually spending $24. That's over our budget. So red is not going to work. So purple better work here, right? At 4 utils per dollar for t-shirts, we're buying 3 t-shirts. Okay? At 4 utils per dollar for movies, we're buying 2 movies. Let's see if that works out. 3 t-shirts would cost us $12, 3 times 4. 2 movies would cost us $4, 2 times 2. So yeah, it does. 12 plus 4 is equal to our $16 budget. So that's our answer. Jose maximizes his utility by consuming 2 movies and 3 t-shirts. And that's it. We used our entire budget, and we're consuming the combination at which the marginal utility per dollar of the last unit consumed of each good is equal. That's it. So, you're going to be asked to do a little bit of that today in your level up. However, some final thoughts on cost-benefit analysis. With producers, costs are both explicit and implicit, and they're included in total economic cost, both of them. This is usually measured for a producer as opportunity cost on the production possibility curve, but in general business, it's economic cost. Benefits are usually measured in sales revenue as dollars. Net benefit is just profit, right, which is total revenue minus total cost, but sometimes that's not what you're given. Okay, maximizing benefit is easy if we do have total revenue and total cost, but if we only have the margins, then we have to find the marginal principal, the last point at which the marginal revenue is greater than or equal to the marginal cost. We're going to work on that a little bit more in a future unit. But for consumers, let's look at both sides of cost-benefit analysis. The cost can be both explicit and implicit, but it's usually measured as just price. The benefit could be a lot of things, but it's usually measured for us right now as utility. Net benefit for consumers is a little bit tougher. It's usually measured as bang per buck because that's like, your benefit versus your cost. But we also see it as marginal utility per dollar Or it could be in dollars to dollars, such as I invested $50 and I got 75 back. This was your buck. This was your bang, right? It was a return on investment, bang per buck. Maximizing benefit for consumers could be just the marginal principle. It might just be the same thing as this. And we've seen that before. However, if it's utility, with one good, we're just finding this point. The top point of the utility curve, the point of satiety, that's just maximizing utility with one good. That's pretty easy. To maximize utility with two goods, we have to go through the process that we just saw on this slide. So I want you to go try that out, okay? Hop into Buzz, check out the level up utility stuff, and apply what we just walked through step by step, that same process, to the questions that are there. And reach out if you have any issues, concerns, if anything comes up on those levels that seems weird that I can fix, please let me know. If there's any further explanation I can give you, please let me know. Anything I can do at all, reach out, okay? Enjoy your 3-day weekend. Hope you have something fun to do, and it should be beautiful out. So get out there and get outside, go hike or something, do something socially distant friendly. And if nothing else, just enjoy some time with your family, enjoy some time at home, get some sleep and catch up on your work and all those good things, all right? Enjoy your weekend, you guys. Thanks for everything so far. Everyone's doing a tremendous job of keeping up with everything. I really, really appreciate it, and you deserve a day off. So enjoy it. See ya.